So classification of groups of specific orders. So first you tell me, if you have a group of prime order, then what can you say about it? If you have a group with prime order, what can you say about it? So if you have order 1 comma all prime orders, then I can say it is abelian. It is cyclic also. Yes, very good. So I can say, remember, okay, so remember, if you have order 1 or prime, if you have order 1 or prime, so if you have order 1 or prime, then it means it is a cyclic group. It means it is a cyclic group, and cyclic group implies it is abelian group. It is abelian group. Now one interesting question they can ask: how many non-isomorphic? Okay, so let's assume order I give you. Let's assume you have order of G. Order of G. Let's assume order of G is let's assume 17. How many non-isomorphic groups are there? Tell me. How many non-isomorphic groups are there of order 17? How many non-isomorphic groups of order 17? Groups of order 17. How many non-isomorphic groups of order 17? Answer is 1. What is the reason? Because it is cyclic. The reason is this. The reason is because it is cyclic. You can notice order of G is 17, which is a prime number, which is a prime order, which is a prime order. It implies G is cyclic. It implies G is cyclic. And every cyclic group of same order are isomorphic. Yes or no? Every cyclic group of same order, they are isomorphic. So you can notice that. You can notice because it is cyclic. So every cyclic group of same order is isomorphic. You already know. This theorem you already know that this we have already seen. Every cyclic group of order n are isomorphic. Are isomorphic means same template are isomorphic, and they are isomorphic to which? They are equivalent to whom? Every cyclic group of order n, they are equivalent. They are isomorphic to whom? They are isomorphic to Zn. So I can say this is equivalent to Z17. So okay, the answer will be 1, because remember this is the importance. This is the beauty. If you have a cyclic group of order 17, then all the cyclic groups of order 17, they are isomorphic to each other. They are isomorphic to Z17. So I can finally say that only one non-isomorphic group is possible. How many non-isomorphic possible? Only one. And if I ask you G equal to 4, now what is the answer? Now the answer is 2. You already know. Now the answer is 2. Two templates you already know. Special, very important templates. So you can notice. So now what about order 4? Order 4, you have two groups. Both are abelian. How many? Can I say both are cyclic? Order 4, 2 abelian, 0 non-abelian, and 1 cyclic, 1 non-cyclic. 1 cyclic, 1 non-cyclic. Because you know the template. There are two templates. You know the template 1 and template 2. There are two templates you already know. Very popular templates. One template is like this. One template is like this, where x is x inverse and y comma z are inverse of each other. Is this cyclic? Is this template cyclic? Yes, this is cyclic. And the generators are y comma z. These are the generators. And the template 2, that is x, y, z, where every element is inverse of itself. Every element is inverse of itself. This template 2 is not cyclic. This is not cyclic. There is no generator for this template 2. Okay, so this is the idea. This we have already seen. Order 4. Order 5, this is a prime. Okay, so that's it. And finally, just I want to tell you that order 6, first time order 6. Can you notice one thing? Can you notice one thing? Order 1 to 5. Order 1 to 5. All are abelian, right? Yes or no? Can you notice all are abelian? Order 1 to 5, all are abelian, because you can notice 1 1, 2, 5, 3, 5. These are prime. These are, I can say, okay, maybe, sorry. I can say that 2, 5. These are prime. These are prime order. And prime order means abelian. Prime order means cyclic. Cyclic means abelian. And you already know 1, 4. These you already know abelian. So order 1 to 5, these are abelian. So what is the smallest non-abelian group? What is the smallest non-abelian group? That will happen on order 6. On order 6, the first abelian, non-abelian will start here. Non-abelian will start here. Okay. So for order 6, I can say this will give you smallest non-abelian group. If I ask you, smallest non-abelian group, smallest non-abelian group, that will have order 6. That will have order 6. And what about 7? Tell me, what about 7? How many non-abelian group for order 7? How many non-abelian group for order 7? 0. 7 is prime. So number of non-abelian group. This is my, if I ask you number of non-abelian group. Number of non-abelian groups. So if you notice, on one hand, I am writing order. On another hand, I am writing the number of non-abelian groups. Then you can notice, if your order is 1, then number of non-abelian group, that will be 0. If your order is 3, 2, 3, 5, 7, then number of non-abelian group will be this. If your order is 4, this will be this. If your order is 6, the first time it will come, then it will come. Remember, 7 is a prime number. So if I say, for example, 7, 11, 13, any prime number I take. So that is the idea. And this is the smallest non-abelian group. Okay, anyway, let's move on now. So these are the ideas.